Mm.
Thank you, Zoom. Okay, so everyone, my name is Chris Jones. Our guest speaker for the AEVA webinar is James Westcott. He's from the Future Battery Industries CRC. That's a West Australian-based research centre. Now, James has been a professional engineer for over 30 years. He's got a mechanical engineering degree from UWA. He's worked globally in the oil and gas, aerospace, fuel cell, electric vehicles, hydrogen and renewable energy sectors in a variety of engineering, leadership and management roles. For the last 6 years, he served on the WA Divisional Committee for the Institute of Engineers Australia, including 2 years as president, and currently leads the working group on sustainability and climate change. James is a strong advocate for electric vehicles and is passionate about the role engineers will play in the rapid decarbonisation of our economy and the adaptation of our society to the impacts of climate change. He now works as the project director at the Future Battery Industries Cooperative Research Centre and will tonight speak about the R&D in the field of battery repair, repurposing and recycling. So we'll have a question session after James's presentation. So if you do have a query, please put it in the chat box. I think there's also a Q&A section. Looks like we've started using the chat box. If you want to keep putting them there, that's fine. And we'll try and answer those in chronological order as they come out. But take it away, James.
Right, thanks, Chris. Hopefully everyone can hear me all right. Right, you're seeing my screen now?
Yes, we are. Fantastic.
All right, well, I guess I've got about half an hour. Thanks everyone for the chance to speak to you today. We're from where we're listening to in Australia. I'm also in sunny Perth, and we're based down near Curtin. So I'm going to talk today three separate parts of my talk. Let's make sure this is working. So what I thought I'd do is going to cover just what the CRC does for about 10 minutes, and then look at a recent study we did about where the opportunities are for Australia in batteries, where we could compete in batteries. And as Chris said, I want to focus a little bit about recycling of EV batteries, repurposing, and what that landscape looks like. So I'll got quite a lot of slides to go through. I'll try and gloss through over the top and just take the key takeaways without getting too bogged down into the detail. If you see a question and you want to ask something, then please note it in the questions and we'll get to it at the end. So just a brief summary of the CRC. We're the 222nd CRC the Australian government has put into place in the last 30 years. We're a 6-year CRC and we're 2 years into it. So it basically brings industry and research together. We've got 61 participants, $58 million in cash, staff in kind, mainly from universities, 8 universities, and 35 million of non-staff in kind. So altogether about $130 million CRC, and we're going in, as I said, we're going for 6 years. So it's well underway. It gives you an idea there of some of the partners there. We've got, as I said, 8 universities. We've got big players such as BHP and BASF, all the way down to small companies, providers, little niche companies, some into software, some into provision of raw materials, all looking at trying to get a position in this burgeoning industry of batteries. This slide just tells you the 4 reasons why we exist, what our strategy is. So we're trying to obviously leverage off our minerals and mining advantage, accelerate the uptake of battery technologies, advance research and capability in battery materials and precursor manufacturing, and facilitate Australian battery industry development. So it's important to know that we're not a future battery CRC. We're really about future battery industries. So if Australia is going to have a ton of batteries, either for transport or for stationary, which seems inevitable that we will it be a totally imported industry, or will we create capability here right across the value chain? And if so, where would be the best place for us to do that? That's really what we're focusing on in our work. Just to give a shout out to the fact we do have an electric vehicle as part of our company. This is the Audi e-tron. Probably quite aware of this particular vehicle. What's important, I think, about the conversations we have with this vehicle is that it's an SUV. So essentially, it can have a tow bar, it can tow caravans, it can do the job of an SUV. And I think that's what's changed out of a lot of electric vehicles that are out there. This one actually fills that SUV market and shows that EVs can be serious at that end of the market as well. It's got a massive battery, 95 kilowatt hours with 36 modules, all liquid cooled. So it's a very heavy vehicle. It's about 2.5 tons. So obviously the regen capability is important for getting back a lot of that kinetic energy. That's a bit of an aside. I just thought I'd better show a picture of that vehicle that's outside our building. So what we've done for the CRC, in the first 2 years, we've done a whole series of baseline reports that look at where Australia is at with various parts of the battery industries. You'll see 5 of the reports we've done there, and 3 more coming out now, focus on material provenance, 1 on recycling, and 1 on battery industry hubs. So the one I'm talking about later in this talk is recycling. They're all available on our website if you want to sort of get into the detail of where we are with all these things in Australia. It's a very complex landscape. What I wanted to do is just break down the 7 sort of parts of the battery value chain. So if we look from left to right, we've got the front end, 3 columns, which is mining of the materials, refining of the materials, and then there's an intermediate step with batteries called creation of active materials. So that's sort of what we call the materials end for the first 3 columns. The next 2 columns are about manufacturing, first of all at the cell level, and then secondly at the battery pack assembly level. And then finally, you've got sort of the deployment, integration, service, maintenance side, and end of life recycling, which we'll talk about later on. So it's important, there's a lot of detail there, but essentially what I'm going to do is when I talk about the battery value chain, these same 7 columns are going to turn up again and again and again to show where we're playing at the moment, where we could play, where Australia could be competitive, etc., with a focus, as I said, on the back end of life for electric vehicles. So at the moment, this gives a summary of where we are active. The darker blue shows where we're most active, and you'll see it's really at that front end. As you'd expect with most things in Australia, we are good at digging it up, and we're not good at doing much else. So similar to iron ore and a lot of materials we send it overseas, we dig up currently 50% of the world's battery minerals, and we tend to send it overseas as ore, and we lose all that value afterwards. So there's a huge amount available there for us if we just kept the materials here and didn't export them all. But right now we have a very immature industry for all those 7 steps of a full battery value chain. So you'll see just the top row there, just the current value where we play. It's dominated by that upfront mining area. As I said, we're 50% of that market, but then we've got less than 1% of all the other 6 stages. The investment really is now the mining companies going to the next stage of refining the chemicals, and a lot of that's going to, from lithium players going to lithium hydroxide. So that's Tianqi, BHP, Albemarle, Wesfarmers, SQM, Covalent, etc., all in that there. So that's where the huge amount of investment is at the moment. But there are other companies playing all in different parts of the value chain. But it's very, very much biased towards that upfront. And the key opportunity for us is to say, well, if there's 6 other areas or 6 other sort of market segments there, where could we best invest? So that's really what I want to look at in this talk. So if you take those same 7 markets, you'll see that we have massive capability at the front end with mining and concentrating. That's where we play, and we don't really have much elsewhere, but we have a bits and pieces. And what we looked at was what's our potential there. So these dials here really show that the column 2, the refining chemicals, is a big opportunity. The precursor manufacturers taking those refined chemicals and making battery-ready materials is extremely high. Battery assembly is pretty high, deployment's high, and recycling is extremely high. So that's really where the potential is for growth. And based on that, we, as the CRC, we've got a whole series or portfolio of projects looking at all these various steps in the value chain. So again, quickly, these are the 15 projects we have, which I oversee. We've got a project in process legacy, which is all the tailings you get off mining and looking at how to make those from waste streams into value streams. It's a big area there. This one is looking at nickel and cobalt extraction and lithium extraction, how we can improve the yields, how we can improve the extraction rates and do it more environmentally friendly. The precursor manufacture is a big one. So the 3 parts of the battery, cathode, anode, and electrolytes. We've made 3 projects out of those: the cathode precursor plant here in WA, the superanode project run out of Melbourne, has about 12 sub-projects, and the future electrolyte systems also run out of Melbourne. Deakin University will have another 10 or so sub-projects. Again, in cell manufacture, we have electrochemical testing of the cell components. For battery assembly, we have the Natural Battery Testing Centre in Queensland. That's coming important now because of battery safety and the need to test batteries that we're importing. You see recently some accidents and fires, etc., that require some sort of national standards around safety. The deployment's quite a big one for us. A lot of interest here in microgrids. That's grids attached to the grid, but also independent islanded systems as well. And particular interest from the mining companies about how to electrify their mines. So a lot of our projects are about testing electrical equipment and improving the amount of electrification on mines, from vehicles to heavier equipment, etc. And finally, recycling project. The size of the bubbles here is really the size of the project itself. These are all sort of tens or millions of dollars of projects, and the recycling one is one that we're looking to make into much bigger second phase, which I'll go through in a moment. So there's 11 projects there, and the final 4 cover the whole value chain, which is looking at supply chain, life cycle analysis, battery industry hubs, and the skills gap assessment of where we're going to need more skills in the blue collar side of batteries. So that's a quick summary of what we do at the here at the CRC. Next part of my talk, I was going to cover some work we had done by Accenture recently, which we launched in Canberra in June with Minister Angus Taylor. And this was really looking at nationwide across Australia, what are our big opportunities for developing Australian battery industries? You know, if you're going to invest $1, where would you put it, and why would you put it there? Where could Australia be competitive? Where are we not competitive? What's needed to sort of get us moving and going in establishing a really robust battery value chain? So as I said, most of this is thanks to Accenture, and I'll cover the main findings here before we get on to talking about recycling. How long have we got, Chris? About another 20 minutes? Yep. All right. So I want to show this chart here because this is really quite something. This just shows what an enabler has happened in batteries over the last probably 10 years. It's this price of lithium-ion batteries. So 10 years ago, we had over $1,000 per kilowatt hour for a lithium battery. And really, because of the volume of mobile applications, laptops and phones, it's come down, 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 down. But this is quite phenomenal now to have lost 88% of the cost of lithium-ion batteries in the last 10 years. And obviously, it gets harder to squeeze the lemon further, but it's projected that we could get down to about $60 a kilowatt hour. $100 is listed by a lot of the industry as being really key landmark to get to. So a lot of the world is now trying to get down to that $100 a kilowatt hour, really through volume gigafactories. And you'll see those popping up in Europe and America and China, really by having massive scale, moving further down that cost curve. But this is really quite something phenomenal. There's nothing like this. If you look at solar panels, wind turbines, none of them have experienced this kind of cost reduction. So it's really worth noting just what has happened with lithium-ion batteries and why it dominates as a chemistry amongst all the other types. Probably some charts you've seen before, just showing the background growth in batteries. Whichever forecast you take, it's going to be phenomenal. Between now and sort of next 10 years, you're going to see a probably 8 or 9-fold increase. 24% year-on growth is something very difficult for any industry to deal with in terms of supply chains and demands and shortages. So I think it's going to be quite disruptive because it's just very hard to increase world's batteries by this much. But this is kind of the demand that we're looking at, and it's really driven by vehicles as much as anything. But it's a phenomenal growth rate we're looking at here. So that's overall with batteries global demand. This then breaks it down by where that's going to be, and you'll see that passenger EVs really dominates here in terms of the volume. It's kind of 16-17% increase per annum. But interestingly, the on-grid and off-grid energy storage systems are going to have higher growth rates, even though they're a smaller proportion. And that's an area where Australia can play it, because that's obviously much more domestic and tied in with the local grid. EVs tends to be manufacturing based, and there's probably little chance that we're going to be manufacturers of EVs, but we're certainly going to be consumers of EVs. So it just shows you there that the kind of the proportions by application. And the next chart shows you by region where it's going to be. So Australia is really very, very small. It doesn't appear on this chart really. You'll see that 2/3 of the global EV uptake is going to be China and US. So they're going to dominate there, and then again Europe to a certain extent after that. So even though we are a CRC looking at Australian battery industries, it's important to know just how minor we are in the whole growth and just how massive this is going to be in US and China in driving the whole battery industry. All right, we're getting back to our seven columns here. I showed you before where Australia plays, and this is really where fills it out further to show, if we're not playing in the next 6 columns, who is actually dominating this. You'll see that China dominates really the rest of the supply chain, which is quite something. We look at 50% of the mining raw materials comes from Australia, then 89% of refining is done in China, with the remaining done in Chile, and that's really the fact that Chile is a big producer of lithium. Then the active materials, again, we don't play at all in that. That's done 2/3 in China. You then get other countries as well as Japan, South Korea becoming part of that value chain segment. Cell manufacturing, again, you'll see the same 3 countries, China, South Korea and Japan, 90% of the market. Battery pack assembly there, Japan has a huge market share in that side of things. The integration, obviously, because that's local, that's the sort of the installation and servicing, that's all highly localized, as you'd expect. And then the end of life, again, China takes a huge amount of the world's batteries and recycles them, so or disposes of them. So you'll see that really the opportunity for Australia is that we get further downstream into all those markets where generally we are not playing right now, but definitely could. This is a very busy slide. I do apologize for it. It was a summary of Accenture's work, and this is really important sort of findings here of, as I said before, if you're where we are today, what would you invest in as Australia? Where could we compete? What would be the key areas you go after? And I'll give you a moment just to kind of familiarize yourself with that. But it's the same 7 columns as before. We've just broken it down into stationary applications and mobile applications with a bit of consumer electronics as well. And it's really saying that Australia has a dominant position in that first column with mining raw materials, and will maintain that as a world leader. But probably our best short-term opportunity, our lowest hanging fruit, is to move further down into the refining area. And you see that now with the miners and huge investment in that, as I mentioned before. And then the next opportunity is to move further down the scale into taking those chemicals and making them into battery-ready materials, which involves quite a complex amount of technology, but quite automated and therefore quite doable for Australia. Third opportunity, sort of in terms of the rank, would be the column 5 there, battery pack assembly. You'll see a lot of Australian manufacturers do that already. They import cells from overseas and assemble them into modules and sell them as Australian battery packs, but don't actually make the cells themselves. Number 4 would be to make the cells ourselves, and that way we would get that whole value chain from 1 to 5. We could produce everything from digging out of the ground to refining it, to producing the active materials, to manufacturing the cells, to assembling the packs. Next, number 5 is the integration, service and maintenance. You see this already. We do this with solar cells, etc. We don't make any solar cells. It's probably an area Australia missed out on probably 20 years ago. We could have been a lot bigger player with solar. We certainly are in terms of installed base, but we don't actually make very much solar equipment. We tend to import it all. And really the only place we play is integration, service and maintenance. So because that will be domestic, that's a big opportunity for us. And then number 6, circular economy for battery materials. It's just a longer term one because it's going to take a while for the huge volume of batteries to come through before that becomes a viable market. So right now you don't see a lot of recycling of batteries because we haven't got that wave of batteries happening yet, but you'll see it happening as the huge number of batteries comes into Australia for transport and stationary purposes. Okay, I've just got a track of time here. It's almost 6 o'clock. So what I want to say here with this chart is that we have very low uptake of electric vehicles, as you see from the left-hand column there. So per capita, and I'm sure people on this call would agree with this, we've got a very, very poor uptake compared to OECD countries, probably 1/7 of what other OECD countries have in terms of EVs, and many reasons for that. But commercial EVs were about on par. And in terms of residential and grid scale energy storage systems, we're actually ahead. So it shows you that per capita, we're ahead on those, and we have got an install base and something from which to create a competitive advantage, even though we're very, very low on our EV uptake. So it's not all bad news. We can use that knowledge of energy storage systems to create industries based on that, and then get the back end of the electrical vehicle market, whereby batteries come into the country in cars. Obviously, we don't make them, but those batteries are unlikely to leave our shores. So we've got to come up with a big industry around dealing with tons and tons and tons of electric vehicle batteries. So the findings were really that Australia has 3 areas we can compete in. So we've got cost advantage through raw materials, security of raw materials. That's really our strength, and cost-effective labour at the required skill levels, particularly when a lot of this is going to be automated. So labour is obviously a disadvantage for Australia, but a lot of this battery value chain that I've spoken about can be automated. Reliability and abundance of key minerals, openness to trade, sovereign risk, etc., helps us to be a reliable provider of batteries. And specialisation, defence, mining, remote areas, all that sort of thing, where Australia has unique conditions, we can get quite a specialised reputation there. So we can compete. We don't tick all the boxes, but we've certainly got some good things to chase. And the final slide I wanted to show here is very, very busy. I do apologise again, but it sort of answers the question. If you said, is Australia competitive with batteries? It's not a simple answer. So I want you to really look at the traffic lights here, rather than all the detail. But it says, okay, well, if you could talk about refining metals as case study, then there's certain cost structure to that. And there's areas where you say we've got a green light, and areas where we've got an amber, and areas where we've got a red, which is, tax side of things. If you went to active materials, which I spoke about before, specific to batteries, that's an area where we've got green lights in other areas. And you could say that in that area, we've got different areas where we're competitive and got a cost advantage. And then further down the value chain, you could look at cell manufacturing. And again, the picture is different. So it's a very hard question to say, is Australia competitive in batteries? It's probably more competitive than we thought originally, because this is a highly automated area and we have so much of the minerals and have such a high mining capability. It's not that difficult for us to move downstream, but obviously it takes a lot to create all these industries. It's a pretty immature industry. It's growing very fast, and a lot of the world is much accelerating and moving into this much faster than we are. So it's a bit of a race to get established in these industries, and Australia really needs to sort of line up a lot of the things required to do this. All right, so in the last bit of time I've got to talk here before we have questions, we've looked at the overview of what the CRC does, looked at some opportunities for where Australia is competitive, and now Chris asked me to say some words about recycling EV batteries. So as I said, the EV batteries are probably not going to be made in Australia. They will come in with the manufactured OEM vehicles, but the way it's looking is that those vehicle batteries will not be allowed to leave Australia's shores. So we're going to end up having a huge amount of electrical vehicle batteries, which we need to do something with. So the thought is, how do we create a value chain all the way down of electric vehicle battery? How do we repurpose them perhaps in another life? So they might have a second life as an EV battery. They might have a third life as a domestic stationary battery. They might then be refurbished. And then at the back end, they might be 80% recycled for their materials. And so you're looking at a sort of whole life cycle for EV batteries. What you don't want is an EV battery coming in with a vehicle, the battery dies or the vehicle dies, and the battery just goes off to landfill. It's something the government is definitely trying to avoid. And there's a huge amount of value you're wasting by just this linear approach to electric vehicle batteries. This one-time use, 8 to 10 years, etc., and throwing that into landfill or exporting it is a very bad idea. And again, we're looking at all sorts of ways that Australian industries could come around and develop value out of electric vehicles. So I'll focus specifically on EVs. This shows, in terms of the type of battery, we haven't spoken too much about it, but essentially this is for the world and also for Australia. About a quarter of the world's batteries are non-rechargeable, what we call primary batteries, and about 3/4 are rechargeable. And of those, the chemistries are lead acid batteries, which is about half. Again, that's really because of all the world's installed base of vehicles. And lithium-ion batteries are just under half. And I know there's lots and lots of other chemistries. There's nickel metal hydride, there's all the flow batteries, vanadium, there's sodium salt batteries, there's zinc bromine, etc. But the key point here is that they're very, very minor chemistries. It's really dominated by 2 chemistries. And the key message here is that lead acid batteries will be dwarfed by lithium-ion batteries. So you're going to see that orange part of the cake just increase and increase and increase and increase. So it's really about the increased install base of lithium-ion batteries, and the waste stream is going to be all about lithium-ion batteries. You know, in terms of bulk, it's going to be dominated by that particular chemistry. This shows you just how big the battery demand is going to be, and why the waste stream is going to be all about electric mobility waste stream. So in terms of energy storage and consumer electronics, yes, there's going to be a lot of waste generated by those, but it's going to be absolutely dwarfed by electric mobility. So this is why there's a great desire to look really long-term at the circular economy for batteries that are used in electric mobility, whether they have a second and third life in electric mobility, or whether they, as I said, have a 4th life in energy storage, or whether you take them apart and refurbish them. What are the requirements to set up industries all around those particular parts? And then back end, how do you recover all the minerals and materials? How do you incentivize companies to get into that industry, whereby we've got a strong business case for doing all those things? The companies pop up and we essentially have the least amount of electric mobility batteries going to landfill or being sent overseas, which is currently the situation. As you well know, there's different types of batteries. So on one hand, the Tesla batteries are over 7,000 small lithium-ion batteries, the 18650 form factor. And you'll see essentially when you break it all down, they're no more than 7,000 little batteries. So the recycling of those is essentially recycling of small batteries once the pack is broken down. But it's very difficult to take a lithium-ion pack like this and safely dismantle it. It's often, still charged. You've got to discharge it. You've got to then take it all apart. There's quite a lot of chemicals involved. So it takes quite a lot to strip down a battery module like this into its component cells, into the 7,000 cells, which then have to be recycled as well. There's quite integrated systems. That's the Tesla. That's one form factor. If you look at the Volt, the General Motors Volt, in this T section where it's assembled in the car, it's a totally different looking animal. Here you've got thousands of pouch cells. So the pouch cells are on the left-hand side at the front there standing up. So it's a whole series of those pouch cells. And the pouch cells are also used in phones and iPads, which is also shown there. So that's, again, a totally different situation when you've got to look at recycling that because it just looks different. It's very hard to automate for all the different sizes and shapes of batteries. There's different types, and again, these will be the two dominating types of batteries which we're going to get in our waste streams. I haven't shown sort of a picture of a battery yet, but essentially you'd know that it's three separate parts: the anode, cathode, and electrolyte. But then there's all sorts of current collectors and separators, etc. So when it comes down to it, you've got a very, very integrated product here that you're trying to, once you've broken that big pack down into a cell, you've still got a very complicated cell here where you've got plastics in a separator, you've got electrolytes in a solution, you've got a bit of copper as the current collector, which you can take off as a stream. You've got the anode, which is essentially a graphite material. And then a lot of the expensive stuff's actually in the cathodes. That's where the lithium sits in a very, very complicated lithiated baked product called lithium cobalt oxide, lithium nickel, cobalt aluminium oxide. It's got manganese in there. That's quite difficult to unwrap all the parts of a cathode and recycle it. You've also got aluminium as part of a battery. And so the key point here is once you've broken down your electrical vehicle into cells, you've still got a very difficult animal to break down further and recover all this specific materials. It's not designed for easily dismantling and recycling. And I showed you this one because this is meant to be just extremely complex, and it shows you all the steps and the technical requirements for breaking down your battery into its components. So all sorts of thermal treatments, crushing, pyrometallurgy, hydrometallurgy, and there's tons of research going on here to how to sort of undo a battery and get it back to its components again. So it's a very, very difficult product to bake, extract down into its original components to try and recover or reuse or regenerate them. So it's very, very, very difficult and elaborate process there you see for all the different steps there. So don't need to take all the details in, but it just shows you how complicated all this is. There is a bit of recycling going, and this shows you 4 companies that are currently active in the recycling space. The 2 in WA, Neo Metals and Lithium Australia. So there are some companies doing it, but it's a very young industry. It's a nascent industry, and again, we're just seeing the beginning of the wave here because the volumes are not coming in as yet, but you'll see in a few years huge volumes being generated. And again, companies like this need to get set up and established. We need the right regulatory framework. We need the right incentives in order for companies to start expanding their capability. A lot of them, I should say, are already doing lead-acid battery recycling. Lead-acid battery recycling is dictated by countries all over the world as being compulsory. So in some places in the world, you're getting 90% recovery rates of lead acid, but it's just a next, an order of magnitude greater to go from lead acid to lithium ion for the reasons I showed you. Just the complexity of lithium ion batteries is much more complex than a lead acid battery. So even though the recycling, you can say, well, there's depots, there's established logistics for picking up batteries. It's a step change to go from lead acid to lithium. And this is what a lot of companies are struggling with now, just how you can economically take apart a lithium ion battery based on your knowledge of lead acid batteries. It's not a sort of progression. It's a different animal completely. It's probably my last slide. This shows you a battery stewardship program that's been suggested by the Battery Council of Australia. I think it got endorsed last year by the ACCC. And this just shows you a whole series of steps required. But the bottom line is that a company would have to, well, there'd be a levy of 4 cents per 24 grams put on every bit of battery that's imported into Australia. And that 4 cents would then provide a huge pot of money to then pay recyclers for gathering and sorting and processing of batteries. So you saw a similar thing in with bottles and cans here in WA. This would be a stewardship that's paid for by the supplier. So it could have an effect then on the cost of batteries in Australia, because this levy obviously of 4 cents would then pay for the back end. So it's a way of stimulating an industry which doesn't exist today. So a lot of work to do around here. I showed this because it just shows you the huge amount of things that are required to put in place to get this battery stewardship scheme going. Again, this is all stuff that's happening now. So I hope that gives you some idea of the complexity of trying to make electric vehicle batteries a sort of a single linear use to a more circular economy, repurposing, recycling industry, and the amount of time we have left, which is not very much because the volume of batteries is going to be massive within the next few years. But all these industries need to get established with the ability in Australia to take on all this work. So that's it for me. I'll open up now to questions.
Thank you very much for that, James. Really appreciate it. For those who peruse the AEVA forums, they can have a read about my exploits of recycling lithium-ion batteries in my shed. It's good fun, and I'm a chemist by training, so I can't help myself. So there's a few questions on the chat box, and there's a couple of official questions on the Q&A box. I might just quickly scan the chat box before it gets too busy. And there was a question here about magnesium in batteries. Are you familiar with the use of magnesium in any cell chemistries through the CRC?
We've got a few. The CRC attracts industry that want to go ahead with projects where they feel there is a potential for them. We've got a lot of players interested in vanadium. I believe there's a couple of players in magnesium who are interested in that particular chemistry, but I think it's quite small. Magnesium has quite a lot of safety concerns, and one of the givens with batteries is they must be safe. So as they try and take cost out of batteries, you're seeing things like graphite being replaced by silicon. That is cheaper, but it then causes swelling, and swelling is bad in batteries. So that causes potentially more fires and more issues. And so there's quite a lot of trade-offs. And I understand magnesium has a good potential voltage, but I believe that it's not so good as in terms of mass battery manufacture. So we don't have currently any magnesium players in the CRC.
And I guess on that subject of advanced anodes, a question's just come through about how long graphite-based anodes will be around for, or will solid state perhaps take over? Yeah,
I saw quite a few things on solid state being the new kind of aspiration for anodes. There's not a lot of graphite out there, and we've got a few companies who are providers of graphite. EcoGraph is part of the CRC. So for now, that's the sort of go-to material, but there's natural graphite versus artificial graphite, and like you say, I think there's people out there saying that solid state will be the step change in anodes in the future. So it's difficult to pick a winner at the moment with anodes. One of our researchers is to look into the benefits of solid state, but again, it has to be safe and affordable.
Yeah, I've in my previous job at Cooperative Technologies, I've spent a lot of time researching the state of play with battery chemistries, and I think the most promising opportunities were in lithium metal anodes. Again, safety, swirling, not without their problems, but they perhaps were the closest on the horizon.
Yeah, a lot of what we're doing is trying to get the cobalt out of cathodes because it's very expensive and doesn't come from many countries. You can replace the cobalt slowly with more nickel and more manganese. And Australia's got very rich resources of nickel. So BHP is very excited about nickel being able to reinvent themselves on a huge nickel industry, and the nickel slowly getting more of the cathode and displacing cobalt. Yeah.
Okay, well, there's a few questions on the Q&A box, and I've just got a question about the metals, but I'll come to that at the end. G-Town has just said CATL, large battery manufacturer in China, has indicated they'll be supplying sodium-ion batteries, even for vehicle applications. Are there any opportunities in that area for the CRC and Australia? Yeah,
sodium-ion is something that we work a lot with BASF, who are a big producer of chemicals, and they're very keen on the sodium salt battery for mining and mobile, stationary applications. it scales quite well. And so I didn't realize that cattle were doing it en masse for car batteries. That's interesting. But yes, as I spoke before, the big players in car batteries are really going to the gigafactories to try and get down below that $100 a kilowatt hour. So some of the numbers you see are quite something in terms of the size of these factories to take on this demand. Yeah, I don't know if sodium batteries are interesting. And
it's interesting because I mean, lithium is actually quite abundant by comparison. So there's perhaps not as many gains to be had by moving to sodium.
I think that in terms of all these battery chemistries, they've all got their place. Vanadium flow batteries, etc. So you might find that there's no one silver bullet for everything. But obviously, if you can create a safe battery en masse to the scale of a gigafactory, you're then really creating some industry leading stuff. And I think Tesla and Cattle, there's 4 or 5 huge manufacturers who will probably dictate where this industry goes. But there'll always be a place for other chemistries for certain applications. Lead acid batteries won't go away. They're very good for backup. They're quite robust and they're well known. So, and they're, as I said, 90% recycled. So lead acid batteries actually are a really good product because they're so highly recycled. And so they'll still be around for, they provide very high current and they're able to sit there for months and do nothing. So backup power, you could well see lead acid batteries still be around for a long time.
Yeah, absolutely. Yeah. A quick question here from Joe Clay. What's your view on national product stewardship for battery recycling? I do know that you had a slide on your presentation on that.
Yeah, well, product stewardship, again, there've been talks about requiring companies like Tesla to, if you want to import or if Tesla wants to sell cars in Australia, what's it going to do about taking the batteries back? And this is a big question in Europe, whereby they're putting the onus on the manufacturer of the car to then look at its life cycle. Here in Australia, they're looking at this product stewardship scheme because that seems to work with other things as well. You'll see that we're not going to be able to export glass, cardboard, tyres. All that was passed last year in big sort of landmark legislation to stop us exporting our waste. And plastics as well was a big one. So I think we're going to see that Australia is not going to be allowed to export these batteries, and maybe a product stewardship scheme will be done whereby, like I said before, you pay a levy on the battery as it's imported, and that then pays at the back end for all the recyclers to get paid for collecting and recycling and reprocessing. That's more likely a model for Australia.
Cool. And I guess I'll quickly jump to Dom Spooner's question about whose responsibility will recycling be, government or vehicle manufacturers or the buyer of the vehicle. I guess you sort of answered that in that it'll be all of our responsibility if that cost is shared.
Yes, in some countries, when you pay for the electric vehicle, you only lease the battery and the battery is owned by the OEM. Other countries, you've got the battery owned by a third party, whereas in Australia, you tend to buy the car with the battery as well. But what the government doesn't want, and we heard this loud and clear in Canberra, is this batteries going overseas for recycling or going to landfill.
Yeah,
so ahead of the wave, they're looking at how to create positive signals whereby companies can confidently set up a recycling and repurposing businesses, but it's very complex. A lot of this is done at a local council. We've got about 550 local councils around Australia, and there's all sorts of rules about transporting batteries. So if you wanted to say all batteries are going to get recycled in New South Wales, then you've got huge issues about how you get them there and the safety, logistics and certification for transporting batteries all around Australia. So it's going to be quite complex as to where the batteries are gathered and how they're going to be recycled state by state. We might just need to have a whole series of state-based recyclers rather than have a single place you can take them all, which you can do in Europe. You could have one place in and just because go into one place.
I was chatting with Chris Dodd, a scrap metal recycler here in Perth, and he said that the greatest issue with recycling batteries is the fire risk. You need to completely neutralise the fire risk before you can send it, which basically makes the case for not sending them anywhere, just processing them locally. Batteries
are recycled now, but the pouch batteries and small batteries for laptops and phones, if you collect 100 of them, essentially that's not a fire risk because they're quite small little energy sources. Once you start collecting bigger batteries, and aggregate them in some sort of collection center, then you start getting fire risk, and you've seen quite a lot of those already, whereby just by critical mass and short circuits, you're getting quite bad fires and possible explosions. So by aggregating all these energy sources, you've got another big problem with transportation and processing. Like I said, a spent electric vehicle battery is still quite dangerous. It's often 40–50% discharged or charged, and so you've got a whole issue about how to make it safe before you even transport it. Let alone, so yes, the transportation is a big one.
Cool. Now, Dave Jones just said the complexities of lithium-ion battery recycling clearly make it very desirable to get the maximum utilization out of batteries before end of life through second and third life applications. I think the CRC is working on a project with a local manufacturer of battery packs to do better monitoring of batteries in use so that they can be repurposed a bit more efficiently.
Yes, correct. We're looking particularly at the repurposing of vehicle batteries, and particularly on mine sites where you've got ultimately the haul packs would be electric, but that's a typical one because they're very high demand, those ones. But essentially, if you've got vehicle batteries, then they can be repurposed as stationary batteries or second life, and quite a lot of companies are looking at that space and looking at all the value that you can get out of it. And yeah, it's definitely an area of interest to try and get companies set up in that space.
No, I just saw there's a question here. There's a company in Australia looking to turn Nissan Leaf batteries into residential house batteries. I think there's quite a few people doing it unofficially, but there might be someone doing it officially.
Yeah, I haven't heard if there's someone doing it officially. Obviously, you've got warranty issues there, but and the Nissan Leaf obviously is now a two-way battery, isn't it? You can have it as a house battery, where I guess the OEM provides some warranty as it being a house battery. I'm not sure.
Might wrap it up there. Although my last question was on the issue of electrification. Something that I've constantly juggled with is if the world wants more EVs, we're going to see a lot more mining happening in sensitive areas. I believe Indonesia has some of the world's highest reserves of nickel.
Yeah.
I think it would break my heart and break many other people's hearts to watch all of that nature be deleted so that we can drive electric vehicles.
Yes.
I know that that's the nature of humanity. That's the nature of progress. But should there be some kind of a prioritization of who gets batteries and who doesn't? So we should prioritize, say, electric buses and locomotives and ferries, and deprioritize electric SUVs.
Yeah, that's a good point. Where do we need it most, and what's the greatest purpose? I think there's going to be a constraint. Like we said, the demand is so high. There's going to be a constraint in the supply chain, and what we don't want is for countries with lower environmental standards to be able to get big market share because they don't have the same requirements as Australia. And hopefully Australia can set an example of good provenance, and almost we're looking at a battery passport where you could look at the origins of your battery and show those chemicals were mined and processed in the best ways possible. Try and give Australian a good brand, if you like, in environmentally as friendly as possible batteries. But you're right, then it does, if in this race to produce batteries, you've got potential for a lot of rogue operations. It's going to be quite a boom industry, and so it's going to be difficult to contain a lot of that rogueness. And the other side you're talking about is how do you prioritize the use of batteries? If it's a bus, then it probably has greater utility than for a single SUV. Yeah, I don't know. I haven't heard anything like that. I think people are not aware yet of the constraints on batteries. You just see huge demand curves everywhere. You've seen the kind of crazy numbers I've shown. That's just for Australia, and this constraint will hit. You see it now with Tesla trying to secure its supply of raw materials, because if it can't secure its materials, it's got no industry. It's got a massive backlog, a couple of years, I think, on its home battery and its vehicles. But obviously, it's relying on other countries to provide the chemicals. That's why it's done a deal here with BHP recently. I think it's desperate to lock up that supply chain. And yeah, I think you're going to see a bit of a race to lock up the various supplies, and whether countries with a lot of very questionable standards get a chance, I don't know. I think it's going to be a difficult thing because it's not regulated yet. It's all happening very quickly. Similar with hydrogen, you could get all sorts of stuff going on because the numbers are just the transition is so high and the numbers are so big.
Yeah. I mean, someone raised the point earlier in the chat box that Afghanistan actually has sizable reserves of lithium and nickel and other battery metals. But I mean, who'd want to set up a mine in Afghanistan right now?
Yeah, and the lithium is essentially rock spodumene in Australia versus brine salts in Chile and Bolivia. And there's certain environmental concerns about digging up brine salts and the processing of, basically to make a battery is like a solar cell. It's quite energy intensive, and there's a lot of these minerals which are now critical minerals like manganese and cobalt, which are in rare supply. So it does change the dynamics, and whether the governance is strong enough to stop the environmental degradation does worry me as well. As what you were saying, Chris, because the demand is there.
I'll just finish up. So Dom Spooner has mentioned that he's a company who's working on a battery that lends itself to easy disassembly, which is a very clever thing. We'd love to hear more about it at a later stage. Dom, perhaps we'll get in touch and we'll put some details up on our website.
Yeah, a lot of people like the flow batteries because they're fairly simple plastic buckets. They're nothing very fancy, but to change them out, you just have to change the electrolyte. So you change the liquid. It might be vanadium oxide or something, but essentially it's not a huge, highly baked up, complex animal as a battery, as a solid state battery. So the flow batteries could have quite a lot of application in Australia and just get refreshed every now and then. And then companies could get into sort of refreshing of the electrolytes, and that might be environmentally better way. So flow batteries have their place as well.
Yeah, I mean, the energy point's interesting. I think it takes about 100 kilowatt hours of energy to produce 1 kilowatt hour of battery, but that 1 kilowatt hour of battery will go on to cycle, 5, 7, 10,000 kilowatt hours of energy over its life. It's the old the story that a 5-cent coin costs 10 cents to make, but it'll do a lot of transactions. Yeah,
and that's why we're saying that there's no chemistry that's sort of the winner. I saw someone just made a statement about zinc bromine flow. Again, all these chemistries have their advantage. There's one out of the west coast of America, which is just an iron flow battery, and that's cheap and cheerful. It's not great, but it's a containerized solution. You can make it en masse, and it's much cheaper. Sort of down and dirty kind of battery, and that has advantages, and it's simple and it's probably more recyclable.
Cool.
So, yeah.
Awesome. Well, fantastic. Thank you so much for coming on and presenting the national webinar tonight, James. That's been really interesting. We'll be putting a recording of this presentation up on the AEVA YouTube channel. You can find the link to the YouTube channel on our website. But in the meantime, keep driving and riding and traveling by EVs, and we'll see you online for the next presentation in about a month's time. So thank you very much.
Thank you.